You know, every disease has a story, and it's not just about labs and scientists. It's about people. It's about a single moment, a single observation that completely changed everything. And today, we're diving into one of the most incredible stories out there, the untold story of sickle cell disease.
Okay, let's set the scene. Picture this. It's Chicago, 1904. The city's bustling, full of energy. And it's right here, in a hospital, that the very first piece of a huge medical puzzle is about to fall into place. And the crazy thing? The clue wasn't found in some high-tech lab. It was found in the blood of a young student, a long, long way from home.
So, who was this student? His name was Walter Clement Noel. He was just 20 years old, a really bright dental student who'd made this huge journey from Grenada all the way to America to follow his dreams. But something was terribly wrong. He was suffering from these awful episodes of just crippling pain, he was exhausted all the time, and he could barely catch his breath. So he goes to see a doctor, a guy named James Herrick. And little did Dr. Herrick know, he was about to see something that would literally change the course of medicine.
So Dr. Herrick takes a look at Walter's blood under his microscope, expecting to see the usual stuff, those nice round donut-shaped red blood cells. But what he saw, it was just bizarre. They weren't round at all. In his report from 1910, he called them peculiar, elongated, and sickle-shaped, like tiny, sharp crescent moons. It was the first time anyone had put a name to the shape of this terrible pain.
And that one single visual clue, the shape of a sickle, is exactly how this mysterious illness got its name. It became a disease defined by what it looked like.
I mean, the name is pretty straightforward, right? Sickle for that crescent shape he saw. And cell, well, that comes from the Latin word cellula, which means a small room. So the name itself tells the whole story. It's a disease where the very building blocks, the little rooms of your body, are the wrong shape.
Okay, so they had a name for it. But for decades, that's all they had. The why was still a total mystery. Why were these cells changing shape? It turns out the answer wasn't in the cell itself. They had to go deeper, way, way deeper, down to a level no one had ever really looked at before, the molecular level. And check out how long this took. It was more than 40 years after Dr. Herrick first saw those cells in 1904 that the next big breakthrough happened. 40 years. Then, in 1949, this genius scientist, Linus Pauling, he figures it out. The problem wasn't the cell, it was a molecule inside the cell called hemoglobin. And then boom, just 7 years after that, in 1956, Vernon Ingram nails down the exact problem, a single tiny change in one amino acid.
And you have to understand this was a huge deal, a total game changer. Before this, people thought of diseases as these mysterious things, like infections or imbalances in the body. But now, for the very first time, they had proof that a devastating, complex illness could be traced back to one single faulty molecule. This discovery basically changed how we think about all diseases.
So that leads to the next logical question, right? If the molecule is broken, what broke it? To find that answer, we have to go even deeper, right into the instruction manual for our entire body, our DNA. I love this analogy. It makes so much sense. Think of your DNA as this massive recipe book. And the genes? Those are the individual recipes for everything that makes you, well, you. In sickle cell disease, the entire problem boils down to one tiny typo. Just one wrong letter in the recipe for making hemoglobin.
And that one little typo kicks off this catastrophic domino effect. So the typo is in a gene called HBB. This causes the body to grab the wrong ingredient. It grabs an amino acid called valine when it was supposed to grab glutamic acid. This makes a messed up version of hemoglobin. And here's the kicker. Whenever oxygen levels get a little low, these faulty hemoglobin molecules stick together and form these long, rigid rods. And those rods are what physically stretch and warp the red blood cell into that dangerous sickle shape.
So let's compare. A healthy red blood cell is like perfectly designed for its job. It's round, it's flexible, it's squishy, so it can zip through even the narrowest blood vessels. A sickle cell, though, it's the complete opposite. It's hard, it's sticky, and it can't bend, so it gets stuck, creating these horrible little traffic jams in your blood vessels. That's something called vasoocclusion, and that is what causes those unbelievable pain crises.
Okay, so where does this typo even come from? It's inherited, it's passed down. And the way it works is this. For a child to actually have sickle cell disease, they have to inherit that typo gene from both of their parents.
If you just get one copy, you're what's called a carrier, but you usually don't have the full-blown disease.
So we've talked a lot about the science, the molecules, the genes, but it's one thing to understand it, and it's a completely different thing to live with it, to live with the daily reality of that one tiny error in your code, and it can be brutal.
Life for someone with sickle cell is just a constant fight. We're talking about these unpredictable pain crises that are so agonizing they can last for days and put you in the hospital. We're talking about being tired all the time because of anemia, making it hard to just live a normal life. And all the while, these little blockages are silently causing long-term damage to major organs.
For years, the main goal of treatment was just managing the symptoms. And don't get me wrong, medications like hydroxyurea have been an absolute lifeline for so many people. They really help reduce how often those terrible pain crises happen. But managing a problem isn't the same as curing it.
And that brings us to right now, to what is without a doubt the most exciting part of this entire story, because we are standing on the edge of a new era, moving away from just managing the disease to actually curing it by fixing that original typo.
So how do we do that? Well, one of the most incredible approaches is something called gene therapy. The idea is just, wow, you basically take a patient's own stem cells out, use a harmless virus like a little delivery truck to drop off a correct copy of the hemoglobin gene and then put the cells back. The body then just starts making healthy red blood cells. It's amazing.
And then there's CRISPR. Okay, if gene therapy is like adding a new correct recipe to the cookbook, CRISPR is like having a pair of tiny molecular scissors that can go in, find the original recipe with the typo, snip it out, and rewrite it correctly. It's so precise it can fix that single wrong letter right at the source.
And that really sums up the whole shift, doesn't it? We're moving from a world where we just manage the pain to one where we can actually delete the cause. I mean, think about that. We're not just treating the symptoms anymore. We're talking about erasing the disease itself from a person's body. It's just breathtaking.
So we've gone from a doctor spotting a weird-shaped cell over 100 years ago, all the way to having the power to literally rewrite our DNA. The journey of understanding sickle cell disease has been incredible, and it leaves us with this huge, thought-provoking question, doesn't it? As we get better and better at editing our own biological code, can we really delete a disease for good?
Hey, if this story blew your mind as much as it did ours, do us a favor and hit that like button, subscribe, and follow the GeneLens channel. And if you want to explore more stories that are written deep inside our DNA, come check us out at our website, genelens.app. Thanks so much for joining us.